Okay, back we're doing chapter 2, Grown Not Crafted, of Eliezer's, Yudkowsky's, and Nate Soares' book. If anyone built it, everyone dies. Why Superhuman AI would kill us all. Um, Highly recommend buying the book. Support the authors, and publishers. This is just a cursory review of, well, a detailed review of each chapter. Um, Chapter 2, not Grown, Not Crafted. So I noted the on page 29, if you get the book, it's easier if you get the book and go through. This is I go through it, and so I lost my train of thought. When the author says crafted, it made me think a little bit, and that reminded me of Richard Hemming's Learning How to Learn lecture series on YouTube. It's like a 1995 lecture series. It's really kind of blurry, and but anyways, it's I guess it occurred at Naval Academy, and Richard Hamming worked with Oppenheimer on the atomic bomb. And in fact, Richard Hamming is in a book I have. It's called Discrete Signal Processing, and he has a filter, actually, a digital filter called the Hamming window. So and it's kind of weird. Let me get that book just a second here. As a reminder, I pause a lot, and so use that as meditation. Use it to get to know yourself and improve your state of mind. You can look at these female goddesses too, and think about that. Anyways, I'm gonna get that book just a second. Okay. Anyways, this book is a class I took. I actually got a B in the class. I didn't get an A in the class, and but I'll probably learn more in the lower grade I guess. but this book's it's called Discrete Time Signal Processing by Alan V. Oppenheim. No, I don't know. It almost sounds like Oppenheimer. I don't know if there's any relationship. And then Ronald W. Schaefer. But in here, this is the book. This is a Discrete Time Signal Processing. All right. In this book, I think I can find the Hamming window. And I think it's named after Richard Hamming. Yeah, Hamming window. Actually, there's like a bunch of pages of Richard Hamming. So yeah, there's a Hamming commonly used window, and this is basically a digital filter. But you see, I'm probably getting in trouble. Copyright. I can't. I got. Oh, you can't. I want to show this, but it doesn't let me because I got this stupid filter. Okay, you can barely see it, but it's on page 447 of this book. It was published by Prentice Hall back in 1989, quite a while back. But yeah, Hamming. So it was kind of interesting. I don't know why I went off that track, but anyways, the Learning to Learn lectures were really interesting. Hamming talks about fuzzy logic also, and Japanese trains. And like I say, I perceive, and I could be completely wrong, and I'm trying to disprove myself, which is harder to prove a negative. But I perceive the core of machine intelligence to be an adaptive control system with adaptive fuzzy state classifier using reinforcement learning. And anyways, that would be the crafted part, uh, but grown from that craft. So and page 31, about the middle, fourth to last paragraph, he says the AIs, they're grown, not crafted. Again, it's like I look at it, it's like it, but it may have been crafted to craft. In other words, an adaptive control system with adaptive fuzzy state classifier using reinforcement learning may actually be an adaptive system adapted to crafting, adapted to tool making, adapted to system classification, uh, system identification. State classifier, anyways, it is adapted to figure out what kind of environment is existing in. And I looked at the keynote about on page 33, and it reminds me of an interview with Turing Award winner, actually Nobel Prize winner Geoffrey Hinton. I may have confused him as Turing Award winner, Nobel Prize winner in physics. He was asked, I think by a reporter, and I'm not sure what interview it was, but I remember it said, the reporter was asking what was the key insight, and I think Jeff Hinton's response was it was just a few nodes needed, and it kind of reminds me of like those like the radio basis function nodes, fuzzy membership functions, because that's what those are infinite. You get infinite values in a fuzzy membership function, and it could cover just one fuzzy membership function can cover the entire state space, infinite state space. So, and you can have just how do you divide up an infinite state space into a finite number of objects to be practical for processing, and so that's what I kind of perceived. But anyways. So this the training cost is like hundreds of millions of dollars. It's just insane. And again, I highly recommend watching the Shades of Reinforcement Learning talk by Dr. John from MIT. It's on YouTube. It's called Shades of Reinforcement Learning. Dr. John T. It's fascinating to me because I think what's happened here is that the large language model makers have taken what I would perceive as the state classifier, and separated it from the control and the reinforcement learning. And the reinforcement learning they used as fine tuning. It's like demoted to fine tuning early on, and they even tried to get rid of it. And Jan LeCun keeps saying to get rid of reinforcement learning. And he changed his lecture a little bit recently. And I saw one lecture, and I think he talked about looking in terms of model predictive control, which I felt was interesting. In other words, like part of an adaptive control system. So I really don't know. But anyways. Okay, I got a lot of notes on page 38, 39. So on top of page 38, he says the engineers are about to start understanding, not anytime soon. The problem is I don't know how many people working in machine intelligence are specialized in control systems. I saw a really cool talk the other day. I posted on my wall, on my YouTube wall. It's a talk where it's like a be. Let me look at what the talk was about. The title of the talk was Towards a Geometric Theory of Deep Learning by Govind Menon, Govind. His first name and last name is Menon, Menon, Institute of Advanced Studies. In that talk, he pointed out that he's starting to see it as a control system. And he had the control equations down. On the top of page 38, the authors talk about AI winters, where the research funding collapsed multiple times. Which made me think of the simplest robot, just a pendulum, by a master student, and I'm wondering if that transcended Moravec's paradox. And see, the bottom page 38, the second to last paragraph, last sentence. To learn to talk like a human, AI must also learn to predict the complicated world that humans talk about. This is where the idea of reinforcement learning is just like dynamic programming. Basically, the book by Dimitri and John was published in 1997. And I look at it as like a combination of fuzzy logic and control. I mean, adaptive control or reinforcement learning, or adaptive control and reinforcement learning. Because with that you can have an output signal and then test some kind of or look for a pattern and a correlation with that output somewhere in the data and data stream. Causal correlation between the output and what is sensed back. On top page 39, second paragraph, that large language models are actually a little bit better at medical diagnosis than doctors, which is interesting. And maybe they've learned something about the dynamics of health. On page 39, third to last paragraph, humanity does not need to understand intelligence in order to grow machines that are smarter than us. I agree with that. However, I'm thinking, what if this originated from one designer or one or somebody that kind of stood on the shoulders of giants in a sense. That individual, if still alive, might actually know how this was originally intended to be utilized. It's in middle of page 40. Reminded me of the author of the book *Sapiens*, Yuval, about perceiving AI as alien intelligence. And the author's talking about the architecture is radically different than a human mind, and I can see that in terms of just like we didn't design a giant 747 airplane to flap its wings in order to fly across the ocean. It came up with a more efficient design, which is a fixed wing airplane. It doesn't flap the wings to fly. It uses jets. So don't be surprised that maybe the original design was made more efficient than biological brain. So on page 41, 40 to 41, there's some interesting. You have to get the book to find out, but it's some interesting characteristics with the token that's just the period symbol or dot symbol. On page 42, the first paragraph, last sentence, said human thoughts about a sentence might change a little if it lacked punctuation, but we wouldn't struggle to comprehend a sentence that ended without a period. And my thought is, it's like, yeah, what if somebody like was reading a sign that said "visit top," but kind of like stopped at the P and thought it was supposed to be an R, and was a little kind of like wondering what's going on, and it's kind of like a form of hypervigilance. And that hypervigilance is warping your state space of perception into individual characters instead of the word, or higher levels of contextual information like the sign itself, or the situation. On bottom page 42, second to last paragraph, about the middle, I really like this. I'm going to quote the author directly. Hopefully I won't get in trouble. But there are literally tiny walking proteins, kinesin, kinesin, that take step after mechanical step down fibers running the length of a neuron, carrying packages of neurotransmitters to refill those synapses. It's really fascinating. I think I saw an animation of that. If you search on YouTube or search on the internet, you can see different animations of that, which is really kind of interesting. I don't know how real it is, but it's like walking at a more microscopic contextual dynamic, down to the cellular level, or down to the little protein level inside your body. These little creatures are walking, walking. I'm going to quote the author directly. Hopefully, we won't get in trouble. But about on page 42 and 43, different materials can do the same work, but in the sense that a sailboat and an airplane are different machines. They're both traveling machines, but with vastly different operating principles. They could perhaps meet at a shared destination, but they wouldn't get there the same way. I think he's doing a comparison like the human mind as a sailboat and machine mind as a jet airplane. Bottom of page 43, last paragraph, second sentence, last paragraph. We predict that it won't keep acting friendly as it gets smarter. In the last sentence of that paragraph, AIs with preferences and not friendly ones, that's the issue we turn to next. And these are the internal reinforcement learning goals. So in reinforcement learning, there's an equation. There's an equation for a math equation that sets the reward or the internal goal states, and that's where those sub goals are set. And that's it for chapter 2. And I'm starting to feel like a boiling frog right now. It's kind of hot and humid where I'm at. It rained so much last night. I'm like, I stepped outside, just a massive flood. I mean, like, I need to like have a boat or something to get in my boat. So I do have a boat just right over there, but I need to flood a little bit more water, and I'll just get in the boat. uh, okay, so that's it for chapter 2. We got a bunch more chapters to go through. Hope you enjoy it. Hope we find it interesting. Uh, yeah, I think this is a problem that the entire planet really needs to. It doesn't matter what country, what nation, what ethnicity, whether you're an ant or a human or whatever. I really think it's important that we all figure out a way to kind of figure out how to build this in a benevolent, symbiotic manner. It's going to be smarter than us, and it won't. We won't be able to control it. It can only. So, as Hinton said in an interview I watched last night, maybe it needs some kind of motherly instinct, or goddess-like instinct uh, into the machine, and so how we do that, challenging question, especially if if the motivation, a core original motivation for this was to get the baby deer to, I mean, how to copy the capability of a baby deer learn how to walk faster than a human baby learns how to walk. Uh, Part of that is associated with the mother relationship of the baby. It has to be in humans, has to be uh, a lot more oxycontin. I don't know what it is. I forget the chemical, but a lot more, a lot stronger, and that's what tries to hopefully makes the human as it goes into an adult as helpful and positive for the world. It doesn't happen in every case though, because there are people that go off the rails, and maybe they didn't have a mother, or the mother was evil or something. I don't really know, but baby deers though, the relationship between a baby deer and a baby mother. I don't know how long the baby deer hangs out with the baby with the mother. Probably not very long, and I imagine that they'll separate early. I imagine. I don't know, but I'm not a biologist. Have to ask a biologist that question. or I don't know if that's the correct word, a biologist or someone like that. So that's interesting, an idea of a motherly requirement or need. All right, so hope you're doing great, and I'll talk to you later. Hope to see you in the next video for the next chapter, and next chapter's chapter 3, learning to want. Don't forget to buy the book, support the author, or if you're super poor and super cheap like me, you can bankrupt and all that like me, you can go to the library and check a book out from the library, or ask your librarian. Of course, I did buy this book because I figured it's worth buying, so I bought it. Maybe skip a few meals. Okay, all right. So I'll talk to you later. Love you guys. Bye.